Hey pre-calcers, today we're going to take a look at graphs of sine functions, one of the three main trig functions that we've seen so far. We'll eventually see cosine graphed out as well. Tangent we don't see too much of, but that's okay. We will start with a quick video. We'll take a look at the basics of these graphs. We'll go over a bit more detail and conclude with some examples. Starting first with a video of where I've personally seen sine functions used in the real world. These examples are always kind of a stretch whenever a math teacher gives them to you, but I thought this one was kind of cool. So let's take a look at this one. This is going to be the FDR skate park, which is under I-95 in South Philadelphia. Let's take a quick look. You see a lot of waves. A lot of transitions. That's not me. A lot of graffiti. A lot of shoes up there too. Maybe your Yeezys are up there somewhere. But the main thing that resonated with me on this clip would be the following. We see this little bump in the skate park, and that's the main place that I want to focus on. Because as we move forward, these sine functions take this type of wave formation where it goes up and then eventually over time we'll see that it goes down and then bounces back up. I know that this example might be a stretch, but I'm sure you've all used Siri before, so let's take a look at what Siri is like. So another place that you might have seen these functions before. We're going to talk through a few basic examples for the graph, so let's take a look at those. We'll just be focusing on the sine portion for today, so don't worry about cosine. We'll go over a few basic logistics on this. When we're being asked to graph out sine functions, they may look just like this scenario here, where we have some term outside the function called a, which represents the amplitude, which is going to measure pretty much how far away from the center these lines will go. So if they were graphed out like this, the amplitude, think of this kind of in a music sense, this would be considered our amplitude, which is really just the distance from the highest point to the middle. So we think of that as a distance. And that kind of will change over time. Sometimes we'll see a heavy amplitude where it's going very high up and then swinging back down. Sometimes we'll see a more low-key one like the one sketched out here. Those will change over time. We take a look at the b term, which is normally in front of x. So for the most part, we'll see like sine and then some term in front of x, or some term multiplying with x, which affects the length for one complete wave or one complete cycle. So where this says wave, occasionally we'll call it a cycle, where if we see how this was first sketched out, it went up and then down, this would be considered a full cycle, because as this continues to the right, that just does the same thing. And we use this equation here to talk about the period, which again is just the cycle, or how long it takes for a full cycle to complete. So we take 2 pi, that's referencing our unit circle, and then we divide that by our b term, which again was in front of x. Occasionally we'll be shifting these lines to the left and to the right with a horizontal shift, which is measured with whatever is subtracted from x or added from x. We don't see that too much here, but in time we will. And also a vertical shift, where this final number way out here will affect if this sine graph, like let's say normally we have a sine line that looks like this. If there was a vertical shift, sometimes we'll have to take the whole graph and start it up a little bit higher than normal. And this is okay, that can happen, and that's based off of this vertical shift. We'll take a look at the general way that the sine function is graphed out, where if we look at this, our amplitude is 1, which makes sense because from the top point here to the halfway point of the cycle, or of the hill of sorts, that's just 1 because it's from 1 to 0. The b term, since there's no term in front of x, we assume it's just 1. Our period, in this case, lasts for 2 pi, which makes sense because if we look at how long it takes for this full cycle to conclude, it happens over the span of 2 pi, which makes sense because if we recall the unit circle, this always was measuring from 0 around to 90 degrees, then to 180, then to 270, and then to 360, or in this case 2 pi, if we're dealing with radians. Radians is how we're going to use most of the sketches for this. We see that there's no horizontal shift because there's nothing inside x, or inside like the parentheses with x. And there's no vertical shift, really, because there's no term added out here. So it makes sense that our vertical shift is where y equals 0, because we're not adding anything else. Cool. So let's take a look at some examples for this. In this scenario here, we're being asked to identify the amplitude and the period of g of x equals 4 sine of x. And we're going to sketch out if there's a transformation at all. Nothing too crazy here. Well, I know that there's nothing inside parentheses, like it's really just x on its own. So that would imply that there's no horizontal shift. There's no term being added at the end, because we could really just rewrite 4 sine of x plus 0, which implies that there's no vertical shift. We can talk the amplitude though, because the amplitude deals with this term in front of sine of x. So we have an amplitude of 4. And since there's no term in front of x here, our period is still 2 pi. All right, so how can we graph this out? We know that previously with the example, this was measured from 0 to 2 pi. We know that halfway it hits the middle of the graph again. So this is dealing in radians, 0, 2 pi. I'll sketch out a little table for you here. So when the degree is 0, we're at 0. When it's at pi, we're at 0. When we're at 2 pi, we're also at 0. But now for the amplitude, we have to make sure that this goes up 4 units instead of just the 1. Because remember, that's going to measure a distance from the top to the center line. And since there's no change in the center line, we just have to make sure that this goes up to 4. 2, 3, 4. Plot that halfway in between 0 and pi. Do the same thing down here. 1, 2, 3, 4. Plot that halfway in between pi and 2 pi. And just draw a nice curve as we hit each of these points. It can be a little tough to show how at first, but just take some time to get this going. Cool. Some other points that we can map out halfway in between 0 and pi. What do you think this angle is going to be here? If we're halfway between 0 and pi. You should be saying pi over 2. And the outcome there's 4. halfway between pi and 2 pi would be 3 pi over 2, which makes sense because we kind of broke up this segment of 2 pi into 4s. So pi over 2, 2 pi over 2 is just pi. It makes sense that this would be 3 pi over 2. And that outcome is just -4. And so boom, this one's done. There's no horizontal shift, no vertical shift. The amplitude was 4 and the period was 2 pi. Pretty simple. Let's see what else. We'll deal with one that's a little bit more challenging. If you're feeling confident with this, maybe pause the video and give this one a shot on your own. But I'll talk through this one. We definitely have an amplitude because there's this 4 in the front. So similar to the previous example, our amplitude is 4. We now have this term of 2/3 in front of x. And so what does that mean? If we're going off of the terms that we saw way back on this is saying that our b term is 1. But now in this case, our b term is 2/3. And so this will change how the period of this is going to move. So let's recall, we get our period, which is the distance for one full cycle of the up and then down. If we take 2 pi over 2/3, if we divide with fractions, treat this like multiplication, our 2's can cancel. This leaves us with 3 pi. And so personally, when I graph these out, I'll mark the beginning, which is usually just 0 unless there's a horizontal shift, and the final point that I need, which in this case is 3 pi. So right off the bat, I know a little bit about this. I know that if my angle is 0, the outcome is 0. If it's 3 pi, the outcome is also 0. And so how do we map out the rest of this? This can be a little tough, but recall that in between 0 and 3 pi, I need that full cycle. So I know that halfway in between, I'm going to get another point that's on the x-axis. So halfway between 3 pi, it's going to be 3 pi over 2, which makes sense. It's half of that distance. So this outcome is also 0. And then to get the rest of what we need, this can be a little tricky, but recall that halfway between 0 and 3 pi is kind of the center. So we know that our line should continue to go up. Recall our amplitude is 4. So in between 0 and this halfway point, it's going up to here. And then it should continue down to here. So let's map this out real quick. Okay, so we got that first part. Recall that this was 3 pi over 2. Mapping out this angle right here can be a little tough, but recall that we just take whatever distance this is and divide it by 2. So think of this as 3 pi over 2 divided by 2, which you can then rethink as 3 pi over 2 multiplying with 1/2. So this would be just 3 pi over 4. So this is 3 pi over 4. And the outcome here is going to be this, which is now 4 for the y-coordinate. It's a little tricky to break these down. We continue this pattern for the final exit, the final part of this. So now going down 4 units, this will swing down to here. And to get a hold of this point that's in here, We have a few options with how we could approach this. So far, we've broke apart into 4s. Like, I personally think it might be the best bet to just think of this as like, all right, this was 3 pi over 4. So we had to add 3 pi over 4 to get here. And then we have to add 3 pi over 4 to get here. So if we think of this as 3 pi over 2 plus 3 pi over 4, you can think of this as 12 pi over 8 plus 6 pi over 8. So really just 18 pi over 8, which we can then simplify to 9 pi over 4. And that's about as good as we're going to get. So this final point that we'll take note of in here is going to be 9 pi over 4 with the y-coordinate of negative 4. This section is definitely tough. Recall that on the first page of details we saw, there was a lot there. So if you're stuck on anything that we did, please look back. I know that breaking down these angles can be tough as well, but just think of it in a distance format and then try to break it down from there. I hope this was helpful. If you're stuck on anything, please reach out with questions. Thanks for watching.